In this section, we're going to be looking at computing the least squares regression line. Last time we just looked at finding R, the correlation coefficient, to determine how strong that linear relationship was between data. Now we're going to look at actually calculating the equation for the least squares regression line, and also use the least squares regression line to make predictions, and then interpret predicted values, the slope and the y-intercept of the least squares regression line. Moving on then to our first objective, and that is to compute the least squares regression line. We are going to be using this data that we had last time in section 4.1. The first thing that we need to do is make sure that this is the data that we have in our calculator. Remember, the size of the house we'll put in list 1, the selling price we'll put in list 2. So let's get our calculators out. And I do have the data in my calculator, so I'm just going to clear out the other list because we'll be using those tonight, and I'll show you what we'll do with those. Once you get your data in your list, I want you to go back to the home screen by hitting second mode. Does everybody have this data in their calculator? Okay, moving on then. And everybody remembers how to get to the scatter plot? Yes? Do we need to go through that one more time? Nope. Okay. So in the previous section we concluded that there is a strong positive linear correlation because it looks like these points are kind of clustered around a line. Tonight we're going to look at how we calculate the equation of that line. That line is called the least squares regression line. We could fit any line we wanted through these data, but this vertical distance from the data point to this line is what we call the residual. And the least squares regression line is the equation of a line that would have the smallest distances here from the data points to the equation of the line. For example, if I fit a line through my data points going with a negative slope, I would have these long residuals here, the square difference from our data value to our predicted value. The equation of a least squares regression line is given in the form y equals mx plus b, if you remember your algebra, where m is the slope of the line and b would be our y-intercept. And the y-intercept is just where this graph would cross the y-axis. It would intersect the y-axis. We have formulas that we can use to calculate the value of this b by hand, the y-intercept and the slope, but we're not going to worry about doing that by hand. We're going to let the calculator do the heavy lifting for us, and we'll talk about the steps that we go through to do this on the calculator in just a minute. First, I want to give us some terminology. The variable that we want to predict, in this case the selling price, that's going to go along the y-axis. The size of the house then would go along the x-axis. The variable that you want to predict is called the outcome variable or the response variable. These would be the y's in this equation, y equals mx plus b. The explanatory variable or the predictor variable is what our x's would be. In our calculators, we're going to put our predictor variable, the one that's our independent variable, in list 1, and we'll put the response variable in list 2. You can either call it a response variable or an outcome variable. You'll see both notations depending on what you're reading or where you're looking. So you need to be familiar with both of those. The independent variable is either the predictor variable or the explanatory variable. I've seen response and predictor more often in the research that I've done than the outcome or explanatory variables, but because you may be taking other classes with other publishers' books in the future, you need to be familiar with both, and I'll use the terms interchangeably. The equation for the least squares regression line, if you're going to calculate it by hand, you need to know these numerical values in advance, but like I said, we're not going to do that. So I'm going to jump right down to how we would calculate this on the calculator. The very first thing you need to do, if you're borrowing somebody's calculator or you get a new calculator, remember you have to turn the diagnostics on. And how we do that is by hitting second 0 to get to our catalog. Then we scroll down to diagnostics on and then press enter twice. You'll see the screen once you've turned your diagnostics on. If when you do that process of linear regression analysis you don't see the R and the R squared, this is the step that you need to do. Just keep that in mind if you get a new calculator or borrow a calculator from the math lab. If you're using your calculator over and over and nobody else is using it, once you turn the diagnostics on once, you shouldn't have to mess with it again. Once your data is in your calculator in a list, we're going to hit Stat, go over to calculate, and then you'll see two linear regression lines. One, the A is the slope and B is the y-intercept, and then on the other we have A is the y-intercept and B is the slope. Your book tends to want you to use number 8 here, so that's the one that we're going to use for our linear regression. So I'm just going to hit number 8 on my calculator. Then it asks you what list do you want for your x and your y variables. And whichever list you put your independent variable in, that's what you want to use for your X list. Whatever variable you put your dependent information in, that's going to be your Y list. And then we calculate, and we get this output screen. If this is your output screen, then we would put Y equals A, and in place of A we would use 160.1939 plus B, would say 0.0992 X. So there's your y-intercept and there's your slope. Let the calculator do it for you. Just follow those steps that are spelled out right here if you ever want to find the equation for the linear regression line. Objective 2 then is to use the least squares regression line to make predictions. Well, what I want to do is, if we have our calculator, I want to actually graph this line that we just got, and here's the equation of the line. So let's go back to our graphing calculators, and let's look at the scatter plot and then graph the equation of the line over it. To go into your scatter plot, we're going to hit second y equals, make sure that your plot is turned on and that you have the correct list selected. Your scatter plot will be the first type of graph, and you need your x's and your y's to be list 1 and list 2 for this problem because that's where we put our data. So I'm going to change my y list to list 2 by hitting second 2, and then how do we get our window to display the right shape so that we see all the data? Zoom 9. So we hit the zoom button and then 9, and there's our scatter plot. Now mine actually kind of jumped the gun because I didn't delete it, the equation for the regression line. I wanted to graph the equation line here, and how you do that is we're going to go to the y equals, but we're not going to hit second y equals. If you want to graph a regular line, to graph a function, or let's say to graph the regression line, we're going to just hit the y equals button and then put in your equation. And we use, what does that button look like? It is hard. It just says x, t, theta, and n. Is that right? Alright, the questions are coming in. Why did I put mine on line 2? The only reason I chose Y2 instead of Y1 is because I wanted my line to be red and not blue. I could have easily just changed that color and it probably would have been less confusing. Let me clear this out, and I'm going to do this again just to show you. So you hit your y-intercept plus 0.0992, and then you hit this button right here for your variable. So now it's red. And because we've already done the zoom 9 on our calculator and got the best window to fit our data, now we can just hit graph and it'll graph the line for you. So step 3 would be to hit the button that says graph. Buttons for 1 and 3 are at the top of the screen on your calculator. They're located up here. Y equals is on the left and graph is on the right. You may want to add these steps to your calculator formula sheet. The notes for how to do the scatter plot on your calculator are in 4.1. So right there in your notes, just put a note that says see section 4.1 because we have those steps written down there in your notes. Alright, objective 3 now is to interpret predicted values, the slope, and the y-intercept of the least squares regression line. Oh, we didn't do this example. Let's go back and do this example. We can use the least squares regression line to predict the value of an outcome variable by substituting a value for the explanatory variable in the equation of the least squares regression line. We can even do this part on our calculator, which is why I wanted to graph the equation of this line, and I'm going to show you something on your calculator that will help you do that. With your graph up, if you will hit second trace, and then the first thing that comes up is value, hit enter. It now allows you to put in a numerical value for X, and since we were asked to predict the selling price of a house that's 2,800 square feet and X is the size of the house, I'm going to type in 2,800 for X, hit enter, and it gives me the price then, the predicted price for Y. I can use this line right here to predict the values of Y when I plug in a number for X. And when I do that, I ended up with approximately 438,000. You see that little number right there? That Y value, that's my predicted value. If you don't do this on your calculator with the graph feature, just drop in that 2800 in place of x in the line, the equation of your line, and you can use your calculator to just crunch out the numbers. Remember, x here was the size of the house and y was the price of the house. So when I plugged in 2800 square feet for x, I ended up with about 438,000 for y. That's how you use this regression line to predict values. There are some limitations on this, and we're going to look at those limitations in section 4.3. Objective 3 then is to interpret predicted values, the slope, and the y-intercept of the least squares regression line. The predicted value y hat, and this is the variable that we use for the predicted value for that equation of the line. We have y hat equals, they use b sub naught plus b sub 1 x, where b sub naught would be our y-intercept and b sub 1 would be the slope. We can use this equation that we came up with for the regression line to find an outcome for any given value of x. For any given value of x, the value y hat is an estimate of the average y value for all points with that x value. For example, use the equation of the least squares regression line for predicting selling prices to estimate the average price of all houses whose size is 3,000 square feet. We go to our calculator, and if you want to change that x here to 3,000, you don't actually have to hit second trace again. All you got to do is type in 3,000 since we've already put in a value for x. And we see then that the price that we would expect to pay for a 3,000 square foot house in Denver is $457,800 approximately. We would just drop that 3,000 into this equation in place of x. If we were doing this by hand, we would just replace x in that equation with 3,000, but it's easy to do this on the calculator. And what did I say we get? 458,000. So it's about $458,800. That's about what you would expect to pay on average for a 3,000 square foot house in Denver, because that's where this data came from. Predicting is pretty straightforward. The y-intercept is what they're using the variable b sub naught for. Naught is just an old-fashioned way of saying 0. As long as your data is all positive or your data is all negative, your y-intercept means nothing. But if your data contains both positive and negative x values, then the y-intercept is the estimated outcome when the value of the explanatory variable, the x, is 0. If the values are all positive or negative, the y-intercept doesn't not have a useful interpretation. The slope, on the other hand, does. The slope, remember, is a rate of change. So that slope tells us that if x increases by 1, the slope of the line is how much the y value is going to increase if the slope is positive. And that's pretty much what I explained, and you guys can read this if you want. If the x values of 2 points on a line differ by 1, then their y values will differ by an amount equal to the slope of the line. This fact enables us to interpret the slope b1 of the least squares regression line. If the values of the x variable, the explanatory variable, for two individuals differ by 1, their predicted values will differ by b sub 1, the slope. If the values of the explanatory variable differ by an amount d, then their predictive values will differ by b sub 1, the slope, times d, how far apart the x values are. And this example, I think, will illustrate that. Two houses differ in size by 150 square feet. This is how much the difference in square feet is between the two houses. How much should we expect their prices to differ? Well, in order to do this, if this is the slope, we would take the slope, 0.0992, and we would multiply it by the difference in the houses, 150 square feet. And this is why God gave us calculators. So we go to the home screen and we type in 0.0992 times 150, and we see that the houses should differ in price by about $14,880. Because remember, this y value that we got here was measured in thousands of dollars. So if I multiplied that answer by 1,000, I would get 14,880. That's how the slope is used. So for each single increment or single unit change in x, that slope tells you how much the y is going to change. Since we're changing 150 square feet in this problem, I'd multiply the slope times 150, and that gives me the total dollar amount. Remember, the Y's was the price of the house. On our axis here, we had the square feet down here, and then the selling price of the house up here. So this is all the things that you should be able to do now so far in Chapter 4, and we're going to stop this video.